In the previous video, we learned about our CIP, or Kahn-Ingold pre-log rules, and we were able to come up with an assessment, or a ranking, 1, 2, 3, and 4, of our unique attachments. Once we know our specific rankings, our 1, 2, 3, and 4, we can now describe a handedness, or that very specific chirality. And these are going to be describing whether or not we have a right hand or left hand arrangement between 1, 2, and 3. And that's going to give us our big terms, which are going to be R and S. And if you remember all the way back from our very first episode, our R and S are going to be our descriptors of a stereochemistry at a very specific chiral center. So R is going to be a shorthand of the word rectus. Rectus meaning right-handed or a clockwise rotation. S is going to come from the Latin word sinister, meaning left, which is a counterclockwise rotation. When you're trying to think whether or not you're going to be going clockwise or counterclockwise, you can kind of think about when you're driving a car, if you're going to be going right or left, what hand or in what direction of like a clock you're going to be moving your hand in order to go. Now, what we're going to do is go through and then determine a ranking for just our top 3. So we've gone through and we've ranked our different attachments as 1, 2, 3, and 4. What we're going to do is in our molecule, whatever the 4th thing is, and a lot of time that 4th thing is actually going to be something that's going to be a hydrogen, we're going to take and we're going to rotate our molecule to put that hydrogen all the way in the back. So if we kind of think of our model here, if we say this is, I don't know, maybe a chlorine, a bromine, and a fluorine, and then this is a hydrogen, what we're going to do is we're going to rotate it where we put that hydrogen all the way in the back away from you. So now we just have our 3 main ones. And then we're going to say, does this go in one direction or the other? And that's going to be the handedness that we're going to be looking. So whatever the 4th group is, we're going to need to make sure that it's in the back. And there's 2 different ways in which we can kind of approach that. Once, though, you get it in the back, and we'll talk about that in a second, what we're going to do is we're just going to draw a connection from our 1st group to our 2nd group to our 3rd group. So in this right here, where we have 1, 2, and 3, as we are going around, this is going to be in the opposite direction of a clock. Normally your clock, it'd be like 12, 1, 2, 3, 4, 5, 6, so on and so forth. Normally our clock would go around in that direction. Here we're going from 6 to 5 to 4 all the way to noon. So this right here is showing a counterclockwise rotation. Go ahead and get rid of that just so it doesn't get confusing later. So this is a counterclockwise. And that counterclockwise is going to signify that that is S. And this S descriptor is going to be describing that specific arrangements of 1, 2, and 3. Now, I have kind of a full process here to kind of show you, but also a shorthand. So what you'll do is you will first identify, do you have a chiral center? And that chiral center, you're going to look generally for things with wedges and dashes, as well as for unique attachments. So here I have a hydrogen, a chlorine, a carbon, and an oxygen. I can go in and I can rank those based on my CIP rules. Chlorine is going to be the biggest, oxygen is the 2nd, carbon is the 3rd, hydrogen is the 4th. Once you have those, the proper way is to go through, rotate that molecule so that you put the hydrogen, which is the 4th group, all the way in the back. So then you see 1, 2, and 3. And then you look at the handedness from 1 to 2 to 3. So here, as I see, I go 1 to 2 to 3. That is going in the counterclockwise direction. I'll often abbreviate that as CCW for counterclockwise. And that says that I have a S configuration. Now, the process of going through step 2 and redrawing that entire molecule and putting a group in the back isn't the easiest thing in the world. If you actually have a model kit, that's actually super easy. You can actually make that and then physically turn it, and you won't move your atoms because you're not actually like breaking or anything. All you're doing is spinning it. On a 2D paper, that's a little bit more difficult. So I will often use a shorthand. This is not a perfect always works, but for our sake, and the ones I'm going to give you, this is going to work in all of our cases. When it goes a little bit wonky is when your fourth group isn't a wedge or a dash. If it's on a solid line in the plane, then things can get a little wonky. But we'll give you ones that are a lot more straightforward, especially considering the circumstances. So what we will do for our shorthand is we are just going to say, what does this look like in its current arrangement? In order to make our assessment, our fourth group needs to be in the back. But let's just go ahead and ignore that for a moment and then say, what does it look like in its current state? And in its current state, as I go from 1 to 2 and then 2 to 3, that right there looks like it's going clockwise. I go from like 4 o'clock to like 7 o'clock, then up to noon. So that looks like it is clockwise. And clockwise would normally mean R. However, I know that my fourth group here is not in the back. And because of the fact that it's not in the back, I will generally show like a wedge, for example, of my fourth group. And therefore, it is actually S. Because there's a process that you got to go and you got to take this to spin it to put in the back. And then therefore, you would get the switch. So if your fourth group is in the front, whatever it looks like, it's actually the opposite. So in that current state, in the wrong drawn state to do the clockwise, you would get an R, but in actuality, it's actually an S. Let's go ahead and go back to the example that we did in our previous. So we had here our testosterone. I'm going to go ahead and erase all of the extra stuff that we had here, just so we don't get too much stuff in the way. Let's go ahead and now do our rankings for each of these. So I said that C was number 1, so I have a 1 down here. B was number 2, so I had a 2 here. D was number 3, which was over here. And then A was my fourth, or my last one. So I've now gone 1, 2, 3, and 4. I can then go in and I can do a handedness. So I'm going to start at 1. I'm going to go 1 to 2, and then 2 to 3. And that right there is going to have a rotation that is going to look like it is counterclockwise. It's going in the wrong direction of a clock, which would normally be an S. However, my fourth group is actually in the front as we have it drawn. So when I take it and I rotate it, which I'm not going to do because that's really hard to redraw this in a totally different form, it actually becomes clockwise, and therefore I'm going to say it's R. And you'll see by just recognizing that that fourth group is in the back, or sorry, in the front and not in the back, I can get my assessment without having to go through and redraw that, which is a lot more work. If I then look at that second chiral center, the one that's surrounded by E, F, G, and H, we're going to kind of follow that exact same process. I see that my highest priority was F, so that carries 1. My second highest priority is G, which is down here. My third highest priority was H. And then my fourth highest priority was E again. So when I think about my handedness, I'm going to start at 1, I'm going to go to 2, and then I'm going to go to 3. That right there is rotating clockwise around, because I'm going from like 2 o'clock to 6 o'clock to like a little after 9. So that is a clockwise rotation, which would normally be R. However, I see that my fourth group is not in the back. It's as a wedge. So I would need to redraw it to put it in the back. So this is actually counterclockwise and therefore an S configuration. So in this specific example of testosterone, I could describe the chiral center on the left-hand side as an R and then the right-hand side as an S. And in short, all we're going to do is we're going to use our normal CIP rules. We're going to get our rankings 1, 2, 3, 4, and then we're going to then draw 1, 2 to 3. Find out, is it clockwise or counterclockwise? Clockwise are going to be R's, counterclockwise are going to be S's. And then the one potential extra hiccup we might have is if our, I didn't mean to erase that, sorry. If our fourth group is not in the back, then you might have one little extra thing to do. Let's go ahead and look at one last example, and then we'll go ahead and end the video. So here we're going to go ahead and look at ibuprofen. We are going to go ahead and focus on this, which is going to be our chiral center. I know that it's going to be a chiral center because I see wedges and dashes, and the 4 different attachments are all going to be different. If I'm doing my quick comparison, Let's go and start maybe down here at the wedge. At my wedge, I have a carbon. That carbon is going to be a methyl group, so there's going to be 3 hydrogens which are not drawn. So I can go ahead and write out its assessment as carbon, hydrogen, hydrogen, hydrogen. Over here, I see that I just have a hydrogen, which is going to be my last group, so I'm already going to give it a 4. Actually, I'm going to do different colors for that. We'll do it in blue. That's going to be 4 because it's just a hydrogen. If I look over here on the far left side, that is going to be a carbon, and then connected to it is going to be a carbon through a double bond. So I'm going to count that as carbon plus another carbon, so 2 carbons for the double bond, and then up top there's another carbon. So that's a carbon connected to a carbon, carbon, carbon. This right here is actually a little bit of an interesting way to write out. The CO2H is an abbreviation. So if you have a squiggly line, you have a carbon, you bond to an oxygen, and then to another oxygen, then a hydrogen. This right here is a carboxylic acid. And if we think of the attachments of that carbon, that is a carbon, and it is connected to an oxygen, another oxygen because of the double bond, and then the last oxygen from the alcohol of your carboxylic acid. If I then look at these, I see the first atom for all of those is going to be a carbon. However, the next one's going to differ. In my carboxylic acid, I do an oxygen, so that's going to win out, and that's going to have my priority number 1. I have a carbon over by my benzene, and then just a hydrogen on my methyl. So I can rank those 1, 2, 3, and 4 accordingly because oxygen is bigger than carbon, which is bigger than hydrogen. And then this dashed to a hydrogen is going to be the absolute lowest because it doesn't even have a carbon. Now that I have that, I'm going to ignore my 4th group and just think of my 1, 2, and 3. As I go from 1 through 2 to 3, that right there, this rotation, is going to be going in the wrong direction of a clock. So we're going to call that a counterclockwise rotation. My 4th group is in the back, so I'm done. I don't have to do anything extra, and that's going to be an S configuration. It's only if you have a wedge with your 4th group that you would do the opposite. So here I don't even have to do anything else because my 4th group's already in the back. I don't have to redraw or anything, so that's a super nice, easy one. And I see that this is going to be clockwise with a S configuration. And that's going to be what we're going to do for all of our chiral centers. We're going to go through and we're going to use our CIP rules, and we're going to rank our handedness as either being right-handed or left-handed. And that is going to be our R and S. We'll go ahead and end the video there, and that wraps up everything for that class.